Hello everyone, welcome to another video lecture of Mathematics Solution channel, and today we are going to discuss about the relation between beta and gamma functions. So let's take the statement beta of m comma n is equal to, we need to prove gamma of m into gamma of n divided by gamma of m plus n. So this is what we need to prove. By the definition of beta function, beta of m comma n is equal to integral 0 to 1 x power m minus 1 into 1 minus x power n minus 1 into dx. So this is the definition of beta function, and we'll do this integration by parts. Okay, and now assuming that this is the first function and this is the second function, now we'll solve this integration by integration parts. So we know already, which is equal to, it is u into v. So already we have u, this is the v value, it is u into dv here. So u is equal to 1 minus x power n minus 1, and v value, this is in terms of dv, so v is equal to x power m divided by m, and the limit varies from 0 to 1 minus integral 0 to 1, correct? And then v into du, so here it is x power m divided by m into differentiation of this function will give n minus 1 into 1 minus x power n minus 2 into minus 1 into dx. Now here it is minus 1, here is minus 1, so minus into minus will make positive or plus. And now substitute the limit value. If we go to the lower limit 0, so this term is 0, so 0 into anything, complete value will become 0. Or if you substitute 1, so 1 minus 1 will become 0. So completely for upper limit and lower limit, this entire term will become 0. And here minus into minus will become plus. Then n minus 1 is constant. Here is m is constant. This can be written as n minus 1 divided by m into 0 to 1 x power m into 1 minus x power n minus 2 into dx. Again, this is beta of m comma n. And now just compare this equation here. The power in the second term, 1 minus x power n minus 1, here is n minus 1, so here we got n minus 1, and here is n minus 1, the value is reduced as n minus 2 here, and then m minus 1 here we got m, so the value is here is increasing as a 1, and here also it is 1. Suppose what is the next step if we integrate this value? What do we get? N minus 1, and this value here will get n minus 2 divided by m into, this will increase 1, so here it is m plus 1. So this is the first step. And second thing, you just add the power here. So here it is m minus 1 plus n minus 1, so m plus n minus 2, and here it is m plus n minus 2. If you perform another operation, again you will get m plus n minus 2. And only thing, the constant value will be increasing or varying. So the next step, which can be written as n minus 1 divided by m into, so this value here n minus 2 divided by, this will increase 1, so m plus 1 integral 0 to 1 x power m plus 1 into 1 minus x power n minus 3 into dx. Now again we can check it. What's the power here? Here is m plus 1 n minus 3. If you add these two values, you get m plus n minus 2. Yes, this is fine. And then if you write one more term, what will happen? N minus 1, n minus 2, n minus 3, integral 0 to 1 x power, this will be increasing 1, right? So m plus 2 into 1 minus x power n minus 4 into dx. The denominator value here it is m plus 1, then m plus 2. If you perform this operation up to n, what will happen? It is 1 minus x power n minus n. So this term will become 0. 1 minus x power 0 into dx, right? And here it is n minus of n minus 1, that will become 1. So this is what we are going to do here, and then which is equal to the next term n minus 1, n minus 2, n minus 3 divided by m into m plus 1, then m plus 2, integral 0 to 1. So the next term, it is x power m plus 2, 1 minus x power n minus 4 into dx. And if you continue the same process, finally you will get certain stage while n is equal to infinity. So here you will get n minus 1, n minus 2 up to 2 into 1 integral. We will write the denominator value later, that is 0 to 1 x power. So this term will become 0, 1 minus x power 0. So what is the remaining value here you will get? Already we have checked that m minus 1 plus n minus 1, this will give m plus n minus 2, and here also it will give m plus n minus 2, here also m plus n minus 2, and here also it is m plus n minus 2. Definitely this is going to be m plus n minus 2 into 1 minus x power 0 into dx. And this is, listen, so m plus n minus 2 here, if it is m plus 2, the last term is m plus 2. If it is m plus 3, the last term should be m plus 3. Therefore, here it is m plus n minus 2. So definitely the last term is going to be m plus n minus 2. Therefore, m into m plus 1 up to m plus n minus 2. So this is the last term, and we know 1 minus x power 0 will become 1. Therefore, we know how to integrate this term. Here it is n minus 1, n minus 2 up to 1 divided by m plus 1 into m plus n minus 2 integral. What is the integration of this value? This will give x power m plus n minus 1 divided by m plus n minus 1, and the limit varies from 0 to 1. If you apply the lower limit, here it is 0, so 0 into anything, this will become 0 completely. Here is 1 power, this value will become 1. Therefore, the numerator it will not change anything. So the numerator is n minus 1, n minus 2 into 2 into 1 divided by the denominator is m plus 1 up to m plus n minus 2. The one more term here we have n minus 1. Now look at the numerator, it is like 1, 2, 3, 4 up to n minus 1. We can write it as n minus 1 factorial, n minus 1 factorial, and the denominator, it start from n. If it start from 1 to up to m minus 1, then directly we can write it as a m plus n minus 1 factorial. For that, I am just multiplying the remaining value, okay, and dividing the same value. So that will give m minus 1 factorial divided by, here is m minus 1 factorial into m plus 1 up to m plus n minus 1. Now this value is 1, 2, 3, 4 up to m minus 1, then m plus 1, it go up to m plus n minus 1. This can be written as, here it is n minus 1 factorial into m minus 1 factorial divided by m plus n minus 1 factorial, m plus n minus 1 factorial, and this is the beta of m comma n. Let us take it as equation number 1. Now this problem, it is like, it is a relation between beta and gamma function. Just now we got the value of beta value, right? Beta of m comma n is equal to n minus 1 factorial into m minus 1 factorial divided by m plus n minus 1 factorial. Now we will do the gamma value. What is the gamma value? By the definition of gamma function, how can we write it? That is gamma of n is equal to integral 0 to infinity x power n minus 1 e power minus x into dx. Again we'll do by integration by parts. So now assuming that this is the first term and this is the second term, using the same method by integration by parts, what you will get? So here it is u into dv, right? So that will become u into x power n minus 1 into e power minus x into minus 1, and the limit varies from 0 to infinity, integral 0 to infinity, right? And this is v into du. What is the v value? It is minus of e power minus x into differentiation n minus 1 x power n minus 2 into dx. Now if you substitute the 0 value, this term will become 0. If you go to infinity, this is also again 0. If you want, you can verify by using the L'Hospital rule. So this term will become 0, right? So this is 0, and again we have here is 1 minus, here is minus, so this will become positive, and any constant here we have n minus 1. So n minus 1 into integral 0 to infinity e power minus x into x power n minus 2 into dx. So this is the gamma n value, and just compare here. If it is gamma of n, we can write 0 to infinity x power n minus 1. If it is n minus 2, we can write it as gamma of n minus 1. Therefore gamma n is equal to n minus 1 into gamma of n minus 1. Now using the backward substitution or recursive formula, then we can find this value. So what is the value? We need to find gamma of n minus 1. Therefore replace n as n minus 1. Here we will get gamma of n minus 1 is equal to, this will become n minus 2, and here it is gamma of n minus 2. Gamma of n minus 2. Now substitute this gamma value. Substitute this gamma of n minus 1 in this value equation here. Let us take some a and b. Okay, substitute b in a. What you will get? That is gamma of n is equal to, here it is already n minus 1 into n minus 2 into gamma of n minus 2. If you perform the same operation, finally you will get gamma n is equal to n minus 1, n minus 2 up to 1 into gamma 1. We know gamma 1 is equal to 1. Therefore gamma n can be written as, right? So we know that is gamma 1 is equal to 1, and here it is n minus 1, n minus 2 up to 2 into 1. So this is exactly 1, 2, 3 up to n minus 1. We can replace as n minus 1 factorial. Therefore gamma n is equal to n minus 1 factorial. N minus 1 factorial. Now here n we got. Suppose if I replace n as a m, what will happen? So gamma m, you will get m minus 1 factorial. And if I replace n as a m minus 1, right? N as a n plus m or m plus n, what you will get? You will get gamma of m plus n is equal to m plus n minus 1 factorial. And from the equation 1, we need to find n minus 1 factorial. Yes, we got it. M minus 1 factorial. Yes, we have m plus n minus. Now substitute all these three value. Let us take equation number 2. All these three value in the first equation. Finally, what you will get? So this will become beta of m comma n is equal to this term, that is gamma of n divided by gamma of m plus n. So this will give the relation between beta and gamma function. That's it. Now using the relation between beta and gamma function in the polar coordinate. So that is beta of m comma n is equal to twice into integral 0 to pi by 2 sine part 2 m minus 1 theta into cos power 2 n minus 1 theta into d theta. Already we have that relation between beta and gamma function, that is beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. And here you can write n into m also, because the properties of beta function is beta of m comma n can be written as beta of n comma n. So that you can write either m dot n or n dot m. Now compare these two equations. The left hand sides are equal, therefore right hand side must be equal. So gamma of m into gamma of n divided by gamma of m plus n is equal to twice into 0 to pi by 2 sine power 2 m minus 1 theta cos power 2 n minus 1 theta into d theta. Now substitute, put m is equal to n is equal to 1 by 2, because we need to find gamma of 1 by 2. Now gamma of 1 by 2 into another 1 by 2 divided by gamma of m plus n, that is 1 by 2 plus 1 by 2, which is equal to twice into 0 to pi by 2 sine power 2 into 1 by 2 minus 1 theta cos power 2 into 1 by 2 minus 1 into theta into d theta. If you simplify here, you will get, here it is sine power 1 minus 1, it is 0, sine power 0, cos power 0, because anything power 0 will give 1. Therefore, this will give in 2 times of integral 0 to pi by 2 d theta, because sine power 0 will become 1, cos power 0 will become 1, 1 into 1 it is 1. Therefore, the right hand side gamma of 1, so already we have discussed the previous problem, gamma of 1 is equal to 1. Therefore, this will become gamma of 1 by 2 whole square, and gamma of 1 by 2 whole square is equal to twice into, so integration differentiation get cancelled, theta limit varies from 0 to pi by 2. Now substitute here 2 into pi by 2, so these two get cancelled, and this is the gamma of 1 by 2, right? Gamma of 1 by 2 whole square. Now we need to find the gamma of 1 by 2, take root on both sides, so this will give gamma of 1 by 2 is equal to root pi. And this is the proof by using definition of beta function and the relation between beta and gamma function. And if you like this video, for more updates please subscribe my channel, and thanks for watching.